Good day, viewers. Welcome to Science Spectrum with Don. This is Math 188, the fundamentals of mathematics. And this will be the second part of the second lecture in variation. So from the previous class, we started off with variation. And we learned that variation is the quantitative relation between two or more quantities. So that quantitative relation between two or more quantities we express as a mathematical formula or a function. Now, let me solve a few more examples on the first type of variation, which is direct variation. So I may need to recap a little. Direct variation simply implies the relation between two quantities, x and y, for instance, and this is a sign that shows this x is directly proportional to x, right? Y is directly proportional to y, which implies if quantity x increases, quantity y also increases by the same corresponding proportionate amount. And the same goes with when there is a decrease in x, y decreases also by the same amount. All right, so another example now. Let's take, for instance, that quantity y varies directly to x, okay, raised to a certain power. And I'll give you a pair of values for quantities x and y. So let's take, for instance, when x is 2, okay, we have it that y is 0.4. And let's also see when x is a 4, okay, have it that y is 6.4. So the question is this, okay, the question is this. I want to express, okay, the relation between x and y with a formula or a function, as you like. So solution is this. So y is proportional to x raised to power n, or we say y is directly proportional to x raised to power n, and I could replace this sign of variation with an equals to followed by a constant proportionality k. And I have x raised to power n on the right, and I have y on the left. All right. Now I could stick in the first pair of values for x and y. Y is 0.4 from this first pair of values, and of course we don't know k, and x is a 2 raised to power n. And clearly from here I could find my constants of proportionality by dividing both sides. Okay, I have a 0.4 is equals to k into bracket 2 raised to power n. I want to delete 2 raised to power n. So I could divide both sides by 2 raised to power n, divide by 2 raised to power n. So clearly, k boils down to be 0.4 over 2 raised to power n. This is k. Now, still, I may need to box this now. I may need to box this, because once I could tell you what the value of k is, okay, this defines the formula or the function, okay, that binds quantities y and x together. All right, so let's proceed. Now, let's say, now from this second pair of values of x and y, okay, I want to replace them for, okay, x and y in that formula you see on the board. So we have y is equal to k times x raised to power n. So y will be given to be 6.4. K we don't know for now, and x is 4, and of course is raised to power n. Now, I may likely, okay, find k from here by dividing both sides by 4 raised to power n, right? And I'll delete this out. So k becomes 6.4 over 4 raised to power n. So can you now see that I have a k from the first pair of values, and I have a k from the second pair of values. And of course, the value of k wouldn't change, okay? Even if I stick in different values for quantities x and y, the value of k stays the same. All right, so the next thing I'll do now is, since k wouldn't change, right? So the 2k are the same. So the first k is 0.4 over 2 raised to power n, which is the same as 6.4 over 4 raised to power n, okay? So I just equated, okay? I equates k, okay? That was what I did. So now I could alternate this I could divide 6.4 by 0.4 and divide this term by this term. So this boils down to be 6.4 over 0.4, this over this, that's I've alternated, and I have 4 raised to power n divided by 2 raised to power n. So 6.4 over 4 is as good as, say, 64 over 4. And I have 4, I could express 4 in its index form. How? If you keep multiplying 4 by the least prime number that 4 can divide, okay, you will express 4 as, okay, in its index form. So 2 in 4 is a 2, 2 in 2 is a 1. So 4 becomes 2 times 2, which I could write as 2 raised to power 2, which means 2 is multiplying itself in 2 places. And of course, this is raised to the power n here. Then I have 2 raised to power n. Now, 64 over 4, clearly, 2 in 4 is a 2, 2 in 6 is a 3, 2 in 4 is a 2, 2 in 2, 1, 2 in 32 is 16. So I'm left with 16 over 1 is equals to 2 raised to power 2n over 2 raised to power n. All right, so let's proceed, okay? Let me conserve this space a little. Now, 16 can be written in its index form, okay, by dividing 16 by the least prime number, okay, that 16 could divide. So starting off from 2, 2 in 16 is 8, still use a 2, 2 in 8 is a 4, 2 in 4 is a 2, 2 in 2 is a 1, I'll stop here. So I have 2 times 2 times 2 times 2 in 4 places to give 16. So I could write 16 now as 2 raised to power 4 is equal to, now from this side now, you see 2 is carrying power 2n, 2 is carrying power 2n. We call 2 the base, we call 2n the power. Now the bases are the same. The base, okay, is the same. So I pick one of the base. And since they divide, since these two terms divide, and I have the same base, I will subtract the powers because of the division sign in between. So the first power is 2n, and because of this division sign, I will stick in the minus here, then I have the next power n. It's the same as what I wrote here. So I have 2 raised to power 4, boils down to be 2 now. I have a 2n, and I have an n here. But there's an invisible one here. 2 minus 1 gives us a 1. Then since n is common, 1 times n, okay, gives us the n back. Now clearly, I have 2 on both sides as the base. They delete out, they are the same. So it turns out to be that 4 is equals to n, okay, or we say n is equal to 4. So I've been able to figure out what's the value of n, which is the power to which x is raised to, okay, in this relation. All right, we may need to build this for a while. I may need to wipe this off. All right, okay, so let's proceed. Let's proceed. All right, now having done this, the next thing I will do is to look for k, is to find the value of k, because once I know k, okay, once I know k, it simply means that this term, so once I know k and I know n, okay, this defines the formula that binds y and x together. All right, so to find k now, I'll go back to either the first, okay, expression I got when I stuck in the values of x and y, or the second. So if I could remember, the first value of x was a 2, y was given to be 0.4, and the second value was when x is 2, y is 6.4. Y is a 6.4. All right, so let's move on now. So the relation between x and y is y varies directly to x raised to a certain power. Now I could replace this sign with an equals to sign followed by a constant proportionality k, and of course I will stick in the values of y and x. Y is 0.4 here, and x is just a 2, and this is raised to power n. But so far so good, right? We've found what the value of n is. So from this pair, I could use either this pair or I could use this pair. So you are free to call this equation 1. That's this formula I got, okay, from this first set of values of x and y. I am free to call this equation 2, which is, okay, the formula I got from this set of values, that's the second pair of x and y. All right, so let me use this. So I have 0.4 is equals to k into bracket 2, and of course, clearly, n is a 4. So I could stick in a 4 here. So it turns out to be that I could find k now when I divide both sides by 2 raised to power 4, when I divide both sides by 2 raised to power 4, I'm left with the k. So it turns out to be that k boils down to be 0.4 over, now 2 raised to power 4 simply means 2 multiplying itself in 4 places. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So this gives us a 16, right? So k becomes 0.4 over 16, 0.4, right, over a 16. All right, so let's see, I could still divide this further. This is, let's see, this is the same as saying 4 over 160, right? 4 in 4 is 1, 4 in 16, okay, is 4. So I'm left with the fact that k is equal to 1 over 40. That's okay. So since I know, okay, since I know n, and I found k, which is 1 over 40, I could replace the values of n and k, right? And that defines the function or the formula, okay, of x, the function of formula that relates x to y. All right, so we need to beam this for a while. I need to wipe this part up in a moment. All right, so since I boxed the relation between x and y, okay, to the power to which it was raised, so y from this function now is equal to, now k is 1 over 40, then I have x, these are the 2 quantities in the question, and n itself is just a 4, so this is the quantitative relation between quantity x, y, and x, okay, and that's it. So let's do, okay, I may need to pause it here for direct variation, then let's, okay, go up in my head and talk about the second type of variation. All right, can I go ahead and wipe this part off? All right, so let's talk about the second type of variation, which is the quantitative relation between 2 quantities of variables, such that when there is a decrease of or an increase in one of the quantities, okay, the second will result to a corresponding decrease or increase, so just like the inverse of it. So we move on now to the second type of variation, which we call indirect or inverse variation. Indirect or inverse variation. All right. So this is simply, okay, the relation between 2 quantities. Please, I have to stress this. It's just 2 quantities, please. The relation between 2 quantities. You could say x, you're free to choose x or y or any letter of the alphabet, okay? Such that an increase or a decrease in one quantity, just say, okay, y, would result to a corresponding proportionate. Now this wouldn't be an increase or a decrease anymore, but okay, I have to switch this now. So this would result to a corresponding proportionate decrease now. Proportionate decrease or an increase in the second quantity, okay, in the other quantity, okay, in this case, let's just say, okay, it's a y. All right, so let me express this mathematically on the board, just like we've done earlier on. So while, okay, I wrap this up. If you're new to the channel, you may want to like, share, and subscribe, okay? Because there are a series of topics that will reel out sooner. Thank you. So let's take, for instance, I have quantity y. Quantity y. Now, if quantity y varies indirectly to quantity x, okay, it will be written as this or like this, 1 over the second quantity. So we say y is inversely proportional to quantity x. Then clearly, I could replace this sign with an equals to, followed by a constant k, which will not change even if I replace the values of x and y. And I have a y on the left, and I have 1 over x on the right. So y becomes k times 1 is a k over x. And this is over 1. So I have a pair of ratio on the right and on the left. I could cross multiply. K times 1 gives me a k, and k becomes y times x. So this is the k. Alright, I mean, you need to beam this for a while. Beam this for a while I do an example now. So I'm about to wipe this part off. Alright, can I go ahead and wipe this off? Alright. So let's do a few examples, and we'll talk more about the other types of variation, which, okay, are joint variation and partial variation. And I'll wrap it up for this topic. Alright, so let's do an example. Example 1 in indirect variation. Now let's say quantity y, okay, is inversely proportional to the square of x, for example. So I could stick in an equal to sign here, followed by a constant k, then I have a y here, k times 1 is still a k, so I just have x squared down, and k becomes, when you cross multiply, k becomes y times x squared. So I'll stick in some values now for x and y. So let's say when x, okay, is a 3, okay, let's say y is a 4, right? Okay, and the question is this now. Let's take, for example, let's say when x is 2, okay, let's figure out what the value of y will be. All right, so let's go ahead and solve that. All right, so I have the first set of values for x and y. So this is the formula that relates y to x. So y is equals to k over x squared. So y in this regard is a 4. I have k over x is a 3 raised to power 2. So this becomes 4 over 1 is equals to k over 9. And when you cross multiply, k becomes k times 1 is a k. And I have 9 times 4. And this translates to 36. This translates to 36. Alright, so let's move on. Let's move on. Now, the goal is, I know k, right? So look at the formula again. I need to box this. That expresses the relation between y and x quantitatively. Okay, this is the formula. Now, these are 3 terms here, y, k, and x. So if you were given any of the 2 terms, you could find the third one, right? So we know k, and we were given x, so we could find y, right? So let's move on. So y is equal to k is 36 over, now x here is a 2, is 2, and of course it's carrying, it's 2 raised to power 2. This becomes 36 over 4, and of course the answer is 9. So therefore, y is equal to 9. So you may beam this for a while. Why? Okay, I do other examples in indirect or inverse variation. So you may beam this for a while, and I'll go ahead and solve the other questions. Can I go ahead? Still beaming it. All right. So the next example now, example 2. Example 2, so let's say I have example 2, quantity t, okay, is indirectly proportional to the square root of f. Okay, these are two quantities now. And let's say I give you, let's say t is 7, and let's say f is 2 whole number 1/4. So the question is this: what if I give you another value of f to be 2 whole number, okay, 2/9? The question is this: what is t in that regard? Alright, so solution. So t is inversely proportional to the square root of f, and this, okay, translates to, I could replace this sign with an equals to followed by a constant k, then I have a t here, then this k times 1 becomes a k, so I have downstairs, I have the square root of f. So I'm going to box this. This is the formula that relates t to f, okay? And of course, once I know the value of k, I could stick in the value and I get, okay, the relation quantitatively. Alright. So while I rub this off, if you're new to the channel, you may want to like, share, and subscribe for more content. Okay? As the series of lectures as they read out, okay, sooner. Thank you. Alright, so from this point now, I have a t. The t is 7. T is 7. Write it down here. T is 7. And of course, I don't know what k is, and that's the first thing I would find. Then I have the square root of. Now, f. We were given f to be 2 whole number 1/4. So this is mixed. So I could write it as 4 times 2 is 8. 8 plus 1 is a 9. So I have 9/4. So this term is the same as 9/4. So I just have 9/4. This is 7/1. So this is 7/1. 7/1 is equals to k over 1. That is still a k. K over 1 is still the k. Then it's divided by, now, square root of a over b is the same as the square root of a over the square root of b, and vice versa. So I could now write this as the square root of 9 over the square root of 4. Right? So we have 7/1 is equal to, now I have 2 pairs of ratios here. I have 2 pairs of ratios, and you can't divide 2 ratios, but you could multiply them, okay, and then you flip the second pair of ratio. So I have k over 1, the first pair of ratio, and this is the division sign that I could change to multiplication now, and then I'll flip the second pair of ratio, which is the square root of 4 over the square root of 9. Alright. So this translates to 7/1 is equals to k over 1, that's still a k, times square root of 4 is a 2, then I have over the square root of 9 is a 3. Right, so 7/1 is equals to k times 2 is 2k over 3. Then when you cross multiply, 2k times 1 gives us a 2k, equals to 7 times 3 is 21. So you divide both sides by 2, So it turns out to be that k is 21/2. Now, since I know the value of k, right, I could just replace that here. So I could just replace the value of k here. Alright? So I could just replace the value of k here. And that is, k is 21/2. This is 21. Then I have a 2 down here. Just say times 2 root f. So this is the quantitative relation between quantity t and f. And of course, I have 2 quantities here now, t and f. So if you tell me one, I could tell you the other, since I know what k stands for. Alright, so let's proceed. Let us proceed. So we're given f to be 2 whole number 2/9. So f is 2 whole number 2/9. I could write this as 9 times 3 is 18. Then 18 plus 2 is a 20, so I have 20/9 out of this. 20/9. So t is equals to 21/2 times the square root now of f, which is given to be 20/9. So t becomes 21/2 times, now I can't actually divide this. Okay, so I'll just get a separate root 20 over the square root of 9. Alright, so let's proceed. So t is equals to 21 over 2, right? Then I could just bring this term here. I could bring this root 9 here. I have a root 9, then I have a root 20 down. It's the same thing, just like I did earlier on, okay? When you divide, you can't divide two pairs of ratios, you can multiply, but you could flip the second pair of ratio. So t becomes 21, root 9 is a 3, then I have 2 times root 20, and that should be about 4 points. Let's see, square root of 20. That's 4.47. Let's just say 4.5 to 1 decimal place. So this is 4.5, right? So I could give you the final answer. 21 times 3 gives us a 63 here. So we have a 63 here. 63. Then we have 45 times 2. 45 times 2. So this is just a 9. This is just a 9.0. And finally, we'll divide 63 by 9. And it's a multiple of 9. So this gives us a 7. So that's the value of t. Alright, I may need to wrap it up here. Okay? I will proceed further from the subsequent bulletin. Thank you for tuning in. You may want to like, share, and subscribe for more contents. Thank you.